Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem isomorphic strings. So this is a Leetcode easy problem. In this problem, we are given two strings S and T and we have to determine if they are isomorphic or not. So what are isomorphic strings? Two strings S and T are isomorphic if the characters in string S can be replaced to get the string T. And what are the conditions to convert the characters of S into T? All occurrences of a character must be replaced with another character while preserving the order of characters. That means if character A maps to character C, then all the occurrences of A must map to B and the order of the characters must remain the same. No two characters in the given string may map to the same character. So one character map to a unique character, but one character may map to itself. That means let's say character B may map to character B. So let's see the input and output format. So in the input we will be given two strings S and T, and in the output we have to return a boolean variable, either true or false. If the string S can be converted into T, then we return true, otherwise we return false. Let's see the constraints of the problem. The length of the string S and T may go up to 10 raised to the power 5, while S and T can consist of any valid ASCII characters. So we have 256 valid ASCII characters and S and T may consist of any of those characters. Let's better understand the problem statement using an example. But first let's understand what are isomorphic strings. So two strings S and T are isomorphic if characters in string S can be replaced to get the string T. Second condition is all occurrences of a particular character must be replaced with another character while preserving the order of the character. Then no two characters may map to the same character, but one character may map to itself. So these are the conditions which we previously discussed in the problem statement. Let's understand the problem using an example. So this is an example. We have a string egg and we want to convert this S into T, which is add. Are they isomorphic? Let's see. So can E be converted into A? Let's say we convert E into A. We map E with A. That means whenever we encounter with the character E in the string S or T, we can replace that character with A and vice versa. That means A can be replaced with E in the string S or string T if required. Then we move to the next character G. So G must be converted into D. That means G maps to D and vice versa must also be true. D maps to G. That means we can replace the occurrence of G with D and we can replace the occurrence of D with G if required. Let's see the next character, that is G. So since the next character is G and it does not match with the character here in T, which is D, we already have the mapping for G in our dictionary. That means we can only replace G with D as given here. So we replace G with D. That means G can be converted into A, D, D, and this is T indeed, and hence S and T are isomorphic strings, and the answer is true. So let's see how we can solve this problem. So let's see the intuition to solve this problem. The problem is an easy problem. All we have to do is to create a dictionary for the corresponding words. So let's say we have two words. So this is string T and this is string S and this is string T. We want to convert string S into T, and these are the two hash maps that we use. So we use these hash maps to create the dictionary for the characters of the strings S and T. So first of all we check if the length of these strings is same or not. If the length is not same, there is no way these strings can be isomorphic. so we return false right from there. So this constitute our case number 1. This constitute our case number 1. Then we start traversing the strings from the first character. So we see that the first characters are not matching, so we will need to convert C to D. Hence we say that C maps to D. That means whenever we encounter C in the string S or T, we always have an option to convert it into D, and vice versa. D can be converted to C. Then we move to next character, that is O. Here you can see that they are already matching. Since they are already matching, we map these characters to itself. So O maps to O. So this is a valid condition as we discussed in the problem statement, which is not matching in the two strings. This W must map to and G must map to W, and we exhaust our both strings, and hence we can convert S into T. There's no contradiction that we have here. Fine. So we have case number 2. Okay, so these strings are isomorphic. So what is the case where we have to return false, where there is a contradiction? So that can be the case, let's say COW. So this is the case for contradiction. You can see that COW can be converted into DOG as we have done here. But while we move to the fourth character, we know from our hash map that C can only be mapped to D, but here we need to convert C into A. So that is not possible because we already have C as mapped to D. So this is a contradiction, and hence we have to return false for these strings. Fine. So this is the case where the contradiction arises. So that can be the case with respect to the string S as well as with respect to the string T. Fine, because A also does not maps to C. Fine. So this is how we solve this problem. This is case number 2. So if we traverse over these strings S and T and we do not find any of these two contradictions, then that means we have isomorphic strings, and hence we return true after we traverse these strings clean. Let's see the implementation for this. So this is our is isomorphic boolean function, which checks if the strings S and T are isomorphic or not. So here we compute the lengths of these strings. So this is the case number 1 where we check if the lengths are not equal. That means there's no way they can be isomorphic, so we return false right from here. Then we declare 2 hash maps. The first hash map maps the characters of string S to the characters of string T, while this map maps the characters of string T to the characters of string S. So then we iterate over our strings which are of same length, and we check if we have already mapped the ith character of the string S. If this is the case, then that means the character to which this particular character Si maps to must be equal to Ti. And if it is not the case, then that is a contradiction. So that is the case that we discussed here. C was mapping to some character, but that character is not A. And if this is the case, then we return false from here. Same goes for the string T. If there is a mapping for some character Ti, then the character to which this Ti must be equal to Si. If this is not the case, then that means it is a contradiction, and hence the strings are not isomorphic, and we return false from here. Otherwise, we map the character Si to the character Ti and the character Ti to the character Si, hence creating our new key value pairs in these dictionaries for the corresponding characters at ith position. Fine. After we break out of this loop, we have successfully traversed our strings safely without executing these two conditions successfully. That means we have isomorphic strings, and we return true right from here. Fine. So that's how the solution is working. Let's see the time and space complexity for this solution. So you can see that the time complexity for the solution is linear because we are traversing over the strings exactly once. Then the space complexity is constant because these hash maps has a fixed length of size 256 because these are the various characters that we can have. So we create two hash maps of these sizes. So this is a constant size, hence the space complexity is constant. Fine, let's see the implementation for this solution. So here's our solution class, and this is our boolean function is isomorphic, which takes in the string s and t and checks if these strings are isomorphic or not. We declare our mapping from s to t, which is of size 256. It is just an integer array, and we initialize this integer array to -1 to indicate that initially our dictionary is empty. Similarly, we create a dictionary for the string t. Then we iterate over the strings s. Here we check the condition that if the string lengths are not equal, then we return false right from here. Otherwise, we iterate over the strings, and for the ith character in string s and in string t, we check if the character in string c maps to the character. So then this is the case number 1, where we see that there is no mapping in either of the dictionaries. That means these characters do not map to any character. So we create our new key value pairs for these maps. Then we have our case number 2, which simply checks if the mapping for character in S, mapping for character in T is compatible or not. That means if the character C1, which is the character in S, maps to character C2, and the character in character C2, which is the character in T at ith position, maps to character C1. If both of these conditions are true, then we simply skip this block. Otherwise, if one of the conditions is false, that means this is a contradiction. One of the characters does not map to the another character. Hence, we return false from here. After we have successfully iterated over this loop, that means the strings are isomorphic because we do not find any contradiction in them. So we return true from it. Fine. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java language, and this is the implementation in Python language. So that's all for this video. If you like the video, then do like it and make sure to subscribe to my YouTube channel and give your feedback in the comments. I've attached the codes in the description, so make sure to check it out, and I will see you in the next video. Till then, take care.